our small video series. As promised last time, I want to share some insights into data of blanking process. This process shows effects within blanking that can destroy tools and machines. For the first example in our video series, we focus on a very simple excerpt of data from a blanking process in a mechanical press. Thus we focus on the process within the machine. For a better understanding, I want to explain the machine, process and surrounding briefly. A mechanical press applies a defined movement of the ram in the most simple way by rotation of an eccentric shaft, which is connected to the ram by connecting rods. In blanking, a punch cuts sheet material. Typically, tools are rather closed, so you are not able to see the process. Machines are robust and have typical runtimes of 2 and more decades. In this long period, tools and sheet material may change. Thus, problems can occur and information is needed. This is where we often help to bring new insights into the current process. This data is one stroke from industrial blanking process. As you see, the machine runs with 80 strokes per minute. We recorded this data some years ago in a small project for 1 day or so. Typically, monitoring systems export one peak value per stroke to the control. Since effects at the machine were not explainable based on these data, we were asked to care for more transparency. For deeper insight, PiezoBolts were mounted into the connecting rod and position sensors attached to the ram. Thus we can have way deeper insights into the mechanical loads. You can easily see that the frost data contains way more information than the nominal value. At the maximum pressure peak, you see that eccentric load from process. You can also see that the elastic energy stored within the machine is released rapidly during the cutting. After the cutting, the whole ram flies vertically downward and applies a massive tension stress in the region of 500 kN in the left and the right connection rod. Then the whole system oscillates. The backstroke applies small tension forces and leads to oscillation in lower frequency. Knowing these details and some background of the machine, it becomes obvious that the nominal force is not the major problem. Like in many cutting processes, the eccentricity and dynamic loads are most critical for tool and machine wear. In most blanking processes, nominal force, peak force and/or envelope curves are used for machine protection. This is not constructive for processes that contain dynamic process elements. Dynamic signal elements may be contained in processes that seem to be slow. Thank you for watching until now. Please give us feedback on YouTube or via email. Within the next video, I want to show examples of data that come from a hydraulical press.